Hi everybody, welcome to week 9. So this is the topic of this week, security models. This is the research material that you can read it. This is the topic that I will teach you guys in this slide. So there are 4 things here. First, I will teach you about the security models. Then I will teach you about the vulnerability assessment, Kerberos, and how to use secure the storage. As introduction, basically a security model is a computer model which is used to identify and impose security policies. So that means security means a complete system which is consists of policies, procedure, and also models. Okay, how about the models? No, how about the policies? Policies rules about what must be done. So usually it consists of subject, object, action, permission, and protection. A classification scheme for people, secret, and activity. A common language used by policymakers and security administrators. So here we have two type of model. The first one, discretion access model, or simply we can call as a DAC. The last one is a mandatory access control, which is simply we can call as a MAC. Okay, DAC. As I mentioned before, DAC stand for discretionary access control. So in this control, user have the authority to set up the permission on their own file. The user also can grant permission to other users, for example, SCLs in Windows or Linux. So assume everyone who has permission exercise it responsibly. How about the MAC? MAC stands for Mandatory Access Control. User has no authority to set up the permission. It is a centralized policy admin to set up permission. Each rule maps a subject to an object with a specific set of permission. For example, as in Linux, it assumes no one who has access can be trusted to exercise it responsibly. Even root can have no authority. Trust management basically is a form of security policy which is consists of action, principle, policy, credentials. How about the Bella Padula model? It's a model of state machine model that used for enforcing access control in government and military application. It ensures confidentiality. We base on multi-level of classification. It have levels of secrecy for documents. It also have level of clearance for user. It is progressively more strict classification of data, which is clearance level assigned to individual. User can read data at high level, and user can write data to a lower level. Aggregate data is more sensitive than raw data. False data can move upward and mislead decision makers. is a formal state transition system of computer security policy that describes a set of access control rules that are designed to ensure the data integrity. So that's mean it ensure integrity based on multi-level of integrity. So the level of accuracy for object, for example, that document in data center has more accuracy than document in laptop. It also have level of integrity for user. For example, policymaker might be highest, and then for public might be lowest. A document at certain level is considered reliable by a person with equivalent or lower level. The model has progressively less reliable classification of data. It also have integrity level assigned to information, which are user cannot write data to a higher level. User cannot read data from a lower level. The reliable data must come from a reliable source. Low reliable data cannot be made to be reliable. False policy data can move downwards and misdirect workers. There are many security models such as a low watermark model, Clark-Wilson model, Chinese wall model. Okay, now we describe further about the Chinese wall model. It's a security model that concentrates on confidentiality and find itself application in the commercial world. It's founded by Brewer and Dash model. Basically, it prevent conflict of interest, put resources, people into COL classes. The user can only access resource from one COL class at a time. COL allocation can change with time. Trusted system. Basically a system that rely upon to a specified extent to enforce a specified security policy. Implemented using access control list, Bella Padula, MSC. User are authenticated, restricted access. The user must be trustworthy. It is secure hardware, whether not on the internet. It's locked up in a secure room. It have a ring of security. A gap. There is no automatic update such as Microsoft, Adobe, Assume, Oracle. Assume everyone is on the internet. Patch management is difficult to coordinate. Mission critical systems are never shut down or reboot. Therefore, new vulnerabilities are not patches. Again, systems are easy to compromise once the perimeter is breached. Okay, now we go to the next is a vulnerability assessment. Okay, vulnerability assessment is we can define as a process of defining, identifying, classifying, or prioritizing vulnerabilities in a computer system, application, or network infrastructure, and providing the organization doing the assessment with necessary knowledge, awareness, and risk background to understand the threat to its environment and react appropriately. So it have a black box and white box. So this is uh, the comparison of black box or white box. This is the comparison of static analysis and dynamic analysis. In the static analysis, it examines coordinate data. Of the source code binaries, Use analytic tools to discover the potential of buffer overflow. Disassemble binaries and reverse engineer. Not so good for design or architecture problems. For dynamic analysis, basically is the main running system. It uses debugger tools, DM, sandbox. It also uses fast testing to create errors or create proof of concept exploits. For disclosure, so basically there's two types of disclosure here. The first thing is a responsible disclosure. It reveals vulnerabilities to software vendor, suggests fixes or mitigation, bound to on bug bounty. Some vendor don't want to patch or punish hacker. Okay, for full disclosure, we need to publish all details of vulnerability immediately. Force vendor to patch immediately. Black hats criminal get info immediately and can craft exploit. This is disclosure if you want to put or we want to do vulnerability assessment. Okay, for secure admin in this task, the admin should adopt right policy. The principal or least privilege. It must use a good access control system. The admin should enforce strong passwords. Use well-known, well-tested crypto on and also patch. For physical security, the user should disable USB, lock BIOS, CD boot, cable appliance should be tied properly. Server media network device, we need to aware this thing works properly also. Door, locks, window, access system, distribution backup. So this thing we need to aware, and we need to make sure this thing is work properly. Okay, before we go further how to minimize the attack surface, we need to understand what is attack surface. It can define as a software environment is the sum of the different points where an unauthorized user can try to enter data to or extract data from an environment. Okay, how to minimize attack surface? There are several things. We can use segmented networks, DMZ, internal firewall, isolate machine from internet, default deny on firewall or services, whitelist needed services or application, MAC address monitoring or filtering. I also need to do like a spam mitigation. For network auditing, we need to look up of the business, for example, password policy, such as the strong password. Is it this organization using strong password? How about the single sign-on or multiple password? How about the account lockout password recovery process? So this is the the things that the network auditor will looking for. The network editor usually will make sure the organization apply this thing. Okay, how to do the penetration testing? Okay, in order to do penetration testing, the first thing, this is the general idea, the general step. The attacker, which is the tester, should decide to do what is the simulated attack. The tester should decide whether to do the black box or white box. Before doing the attacking, the tester should have like a written agreement from customer. Take notes throughout the pen test. The tester should report the details of finding and vulnerabilities customer. And finally, after finish the testing, the tester can suggest the mitigation and fixes. Okay, how to do the testing? These are 4 general steps. The first one is enumeration. Network creation by using IP scan, port scan, DNS record. Network reconnaissance is in Terengganu we can call it as coding. In English word we can say was to wash up. Okay. 2. Network vulnerability analysis. In the second step, the activities such as a port scan, fingerprinting, vulnerability service can be used. The third step is a web application testing. In this step, the tester can do SQL mapping injection, XSS testing, JavaScript injection, PHP pass-through injection, and fast testing. And finally, the tester can exploit vulnerability, establish foothold, additional reconnaissance, and obtain privileged information or access. Now we go to next is a Kerberos. Basically, it's a software that acts as an authentication protocol, and a software suite implementing this protocol. It uses symmetric cryptography to authenticate client to service and vice versa. Windows Server uses Kerberos as the primary authentication mechanism, working in conjunction with Active Directory to maintain centralized user information. There are many usages how to use the Kerberos. We can use to log in into other machine in a local area network, authentication for web services, authenticating emails, client and server, and authenticating the use of device such as printer. Okay, how it works? This software basically works by using ticket as token that prove user identity. The tickets are digital documents that store session key, which is a duly authentication a client receives 2 tickets, whether a TGT or service ticket. He also uses a KDC, which stands for Key Distribution Center, that contain of ES and TGS. It keeps a data storing the secret key. It also centralized authentication for an entire network. Each transmission is encrypted. It compares password hashes. The advantage of Kerberos basically is a timestamp ticket that prevents playback attack. It uses a cache of previously used tickets to prevent replay attacks. Tickets may be specific to IP address. It uses symmetric keys, open source version available. This is advantage, and this advantage of using the software. If the KDC goes down, no one can authenticate. If an attacker compromises the KDC, the authentication information of every client and server on the network will be revealed. Requires that all hosts have synchronized clocks. It uses test encryption, which is the encryption is out to date. Secure storage. Basically, Microsoft Acrobat allow for password protection by encryption. The Microsoft creates an encryption key by hashing a password 50,000 times. It makes brute force cracking impractical. Acrobat brute forcing can try 75 million guesses per second. Office brute forcing can only try 5,000 guesses per second. This encryption scheme. So this is the example of the this encryption scheme. We have four here. First one, Windows EFS, TrueCrypt, BitLocker, and Free Compusec. The purpose of the Windows EFS is encrypt the file contents .name metadata. It only work with EFS file system. It can have caches, temp files unencrypted. It also use Windows password as part of private key. How about TrueCrypt? TrueCrypt basically is a third-party solution. It encrypts complete hard drive or TC containers. It mounts as a drive in Windows, which is device in Linux. Provision for possible denial. Hide TC inside another TC. It requires root rights to create an NTFS container, but anyone can mount a TC container and use it. It's shut down since May 2014. BitLocker basically is a Windows technology that creates a plain text partition for pre-booting and encrypted partition for Windows data. It uses TPM to manage keys. Free Compusec is an open source solution. It intercepts drive, read-write commands, and decrypt the stream. It has full drive encryption only. It also modifies MBR to load Compusec driver to mount driver. There is a limitation of the secure source. This encryption scheme keeps a streaming symmetric key loaded into memory during operation. A RAM sniffing attack can extract the key, making the entire drive visible to an attacker. Such as attack require physical access. How about a trusted platform modules? Basically, it's a cryptography chip attached to motherboard of a PC or another computing device. It contains small amount of EEPROM and dedicated CPU, ROM, and temperature sensor. The idea is that all security and cryptography functions performed on behalf of the BIOS and OS are performed by the TPM, which is harder to sniff or intercept because it is hardware. Items such as fingerprint matrix, certificate, key, and password can be stored on the module. The TPM should never display its contents. But the TPM has poor reputation due to its early use in enforcing DRM. Few manufacturers or software vendors put the TPM on mobiles because of this. Configuration has been added to allow the TPM to be backup. So this is the case study. We can see here there are 6 things. No, these are 1, 2, 4. Okay. At the end of the slide, I also include the open question. What do you call the act where an attacker is capable of sending data with the illusion as if it is coming from different sources? You need to choose whether it's redirecting, spoofing, phishing, or denial of services. I hope you can answer this question in the conversation, as I will pass this question to the Canvas discussion. So at the end, I hope you guys can study this slide or this video. Please make sure you submit on the lab assessment, as is a minimum requirement for pass for this unit. So I think that's all for this week. So thank you. Have a nice day.